Wake up, Neo. The Helix has you.
Hi everyone, I'm Dwayne and welcome to the channel. So, Helix forums, Facebook groups, YouTube comments, pretty much anywhere the Line 6 Helix is being discussed, people keep asking when will firmware let me load neural amp modeler captures on my Line 6 Helix? When can I get a NAND block in there? And the short answer to that question, I strongly believe, is never. So I'm going to go over why I believe the Helix will never support neural amp modeler capture functionality. I don't mean the ability to capture themselves. I mean the ability to actually play community captures from other people. But I'm going to go over some real numbers here. I'm going to go over the hardware of the Helix, the requirements of neural amp modeler. We're also going to talk about the premise of could Line 6 actually create their own profiling technology and implement it onto the Helix, something new, proprietary, or are there other alternatives where you could add neural amp modeler functionality to your Helix for cheap? So the agenda for this video is step one, we're going to go over what neural amp modeler requires from just a hardware and software perspective. Then two, the Helix hardware reality. So what the Helix hardware is capable of, the specs of it. We'll try and keep it not nerdy, but basically we'll go over what the Helix has inside of it because not everyone is aware what powers the Helix. Three, could Line 6 clone their own Kemper profile technology in-house, and is going to be workarounds for how you can add in neural amp modeling functionality in there. Okay, so first and foremost, we're going to talk about neural amp modeler and what it actually requires. Well, what is it? What is neural amp modeler? Because to some, it's just kind of like captures are just these things that allow you to sound like amps and whatnot. But what actually are they? So neural amp modeler stores each capture has a 32-bit WaveNet style neural net. So basically a machine learning algorithm based approach to storing the data. And the file size for those can be 5, 10 megabytes upwards. I've seen a few where they're quite meaty in comparison to a Line 6 Helix preset, which is what, 5, 10, 15, 20 kilobytes. So kilobytes to megabytes, we're already talking, quite a substantial difference in file size there. So I was looking around and people are actually, there's this whole DIY maker community around people using Raspberry Pi devices to try and make their own neural amp modeler playing devices for cheap, I guess. Well, Raspberry Pi can get expensive as you start tinkering and adding stuff to it. But basically, using a Raspberry Pi 3, which is 1.2, just a single 1.2 gigahertz Cortex A53 chip.
21 gigawatts!
So what I found was a standard neural amp modeler capture on that Raspberry Pi 3 1.2 gigahertz chip will actually slam about 90% of the CPU. So when you think of a CPU, there's utilization. 100%, you can't go over 100%, that's the max. 0, so not being used, 100 being used. So 90 is pretty damn close to the top. That's 10% headroom, not a lot there to really do anything else. And then there are other variants of neural amp modeler. There's a couple, there's light. So a light drops to around about 60% utilization, so getting better. And then there is also a feather variant, which drops to around about 40 from what I could see. And there is work on smaller models, a nano model. I don't know if that's public, but basically the goal is to try and get neural amp modeler to be supported on more devices. And you're probably thinking, okay, well, that sounds promising. They're trying to make it more powerful, but less hardware, computational and expensive. But the problem is with those different levels of neural amp modeler profiles, so the top one being the 90% figure I was talking about, then 60 and then 40, nano, let's say maybe 30, 20, I have no idea, there's no figures. There's compromises that are made there because as you start bringing down the utilization, you have to compromise on something. So that usually will mean less bits, less detail in the capture, which means they don't sound very good.
I'm gonna take my horse to the old town road.
And this is something that's actually acknowledged by the developer of neural amp modeler, that the smaller variants just don't have the high quality sound as the top ones. The top ones sound amazing. I think they're just as good as the Quad Cortex, the Kemper, and a lot of the ones I've heard. And I think it's absolutely incredible. But as you start getting down that rung, there's compromises, right? If you want to run on lower powered hardware, you got to make a compromise somewhere. So try and remember those numbers, because now we're going to put the Line 6 Helix silicon under the microscope for a minute. Just basically what the chips are inside, memory bus capability, all that kind of stuff in there. So the Helix Floor runs 2 analog devices, ADSP 21469 chips, DSP chips, and each core of those is 450 megahertz, and it pushes around 2.7 gigafloating point operations per second. You can just call it G-flops, gigaflops, whatever you want. It doesn't matter. And it uses a 32-bit SIMD vector unit. So SIMD is single instruction, multiple data. It's basically just how the chip works in terms of what it's told to do, what it does, and then what it spits out. You don't really need to know that because it's just technical mumbo-jumbo that most people don't care about. Basically, it's the capability of the chip, right? So add those two up, 2.7, 2.7. That gives you 5.4 gigaflops total. Now, that may sound impressive on the surface, but those cycles are juggling all of the audio. So these Shark chips in here, they are just for audio. They're low latency, high performance chips. They are specialized just for audio. They're not doing anything else other than audio. So these things are juggling the amp algorithms, the convolution engine for the cabinets. I think there's 8 oversampling filters in there. I could be wrong about that figure, but oversampling filters in there, USB audio, and anything else I may be missing in that flow of how the audio is structured and works on the Helix. And then, of course, you've got the other stuff on there, like the color screen, foot switch polling, all that stuff. That is not using the DSP on the chips, but you can see a picture there of that these chips are doing a little bit more than just playing your amp modeling. They're responsible for the sound of the device, which is the main aspect of this. So think about this, for example. One regular amp model would inhale an entire Shark chip, quad core on the Line 6 Helix. So that's one chip just completely gone. So even a feather profile would leave crumbs in terms of what's left to actually do the rest of that stuff that the Helix needs. So that'd be bye-bye stereo IRs, bye-bye dual amps, bye-bye delays, reverbs, definitely no pitch effects, pretty much nothing. You would just turn a $1,500 workstation modeler into a single amp block, basically. Now, just imagine how ridiculous that is. A Helix that can only power one block. Like, why would you bother? You just buy something cheaper, right? So that's one limitation there, is the chips just don't have that much power to be giving out, which is why they have to keep reinventing the software, which I think is really smart, and it really highlights how clever the developers at Line 6 are in terms of being able to just constantly make the software more efficient, to keep finding new ways to utilizing the hardware and just getting new life out of it. Have you ever gone and tried to use an old iPhone or something that maybe is in a drawer from, maybe even 5 years ago, and it just feels so old and sluggish? And a lot of that, is because Apple stops updating those phones after a while. All phone manufacturers do. They get sluggish just because the software gets bulkier. The hardware can't grow because it's a fixed point in the whole equation. The hardware does not change. It's locked in. The software can change. And in theory, phone manufacturers could find ways to keep finding new ways to breathe life into phones, but they don't, because that doesn't make money for them. And, for Line 6, they're not making money putting out these updates. The software development time and whatnot. The Helix sales, I'm sure, have slowed down over the last few years because it's a 10-year-old unit, and people have this thing in their mind where they need the latest and greatest, and they think 10 years means it's outdated, it's a relic, it can't do anything. But we all know that's not true. If you own the Helix, it's an amazing unit. DSP limited at times, sure, but it's an impressive unit. And yeah, Line 6 have done a really good job of highlighting that you don't just have to keep reinventing hardware, you can just write better software. And a lot of companies, especially in the web development world, because I'm a software developer, in the web development world, especially as computers have gotten more powerful, people have just stopped caring about performance and optimization because the hardware is so good now on computers that you can just get away with shipping slop and junk, and it's not optimized. And everyone has 32 gigabytes of memory and these 4 6-core CPUs. So in terms of like a desktop PC these days, everyone is just, developers are spoiled for choice because they can just get away with shipping mediocre code. But a device like the Helix, where the hardware is more limited, you have to really be laser focused and really intentional about every little bit of code you write, because that has to be processed and everything has a cost. So massive kudos to them. Back to the hardware discussion now. So the Helix shares one 16-bit DDR2 double data rate 2, if you want to know what the abbreviation is, but you're probably familiar with DDR2 because of desktop memory. Basically, that's the bus that pretty much dictates how the chips communicate with each other and how everything flows around. Think of them like highways, right? So half the core clock yields roughly 425 megabytes on there. A 10 meg NAM model must sling its weights across that same highway every 1,024 samples, which is, on the surface, if you're doing the math, that's insane. Right beside 2 long IR engines, that is just a traffic jam. So think of a funnel and think of four different pipes feeding into that funnel, right? It's feeding in, and then the funnel, obviously the spout is big at the top, everything's all good. But what limits a funnel? It's the spout at the end. A tiny spout, only so much is going to be able to come through, despite you've got all these different pathways of data flowing in constantly into the funnel, or liquid in this case, and then it can only come out so fast. That's the bus. So the bus is kind of like, it's the link. It's like the brains, it's like the spinal cord, the brainstem, whatever, connecting to your brain and all the different pathways in your body going to your brain, the CPU. If our bodies only had a few pathways, we would just be super primitive creatures because we would be super slow. We wouldn't be as smart. Same thing for hardware. Like the more hardways, the more faster data can flow around. And it sounds, I probably look crazy swinging my hands around stuff like this, but that's kind of the best way to explain it if you're not a technical person. So yeah, a traffic jam. You're slinging such a large neural ant model profile around. That's a traffic jam, and you can already see where I'm going with this. The Line 6 hardware cannot sustain a neural amp model capture. It couldn't even really sustain one of the lower, lesser quality, crappy ones that you wouldn't even want because they don't sound good. If you want neural amp modeler profile captures, you want the best of the best. You want the top ones. You want the most bits. But that, of course, requires the hardware to do it. So even if Neural DSP found a way to kind of get around that hardware limitation somehow, let's just say they're wizards, I don't know, they've got some super magic dark AI writing their code that finds a way. There's another blocker here in terms of what powers these neural ant modelers, and NAM code is C++, with Eigen, I don't know how you pronounce it, tensor math that's been tuned specifically for x86 and ARM architectures, basically. So that already right there makes it ineligible for the Helix because you can't run these NAM models on Shark processors. There may be someone out there that's done it. There may be work that's ongoing to do it. But generally, a lot of these devices, like the Quad Cortex, it has one of the newest Shark Plus chips, which actually has an ARM core in it. And I believe that's probably what they're using for their profile capture functionality as well. But these Shark chips, my understanding is they're just not designed to do profiling. And that's the only chip inside the Helix. There's no other chips inside. It's these two Shark DSP processors, maybe a couple little microcontrollers for the screen and stuff, but those things are not chips that can run complex instructions like a NAM capture. So you've got that problem where the software is simply would have to be rewritten. They would have to go and port the kernels, the firmware to support 40-bit floats, then Harvard memory, narrower SIMD. That would be months of hand-rolled assembly for slower results and probably not even going to work, as I say, because the Shark chips just wouldn't have the ability, especially these ones in here, which are like 15 years old. They would just not even have the ability with the best designed port to Shark that could actually run these, where they would sound good. So you've got the hardware limitation, you've got the software codec limitation because of the chips are different. Let's say Line 6 gets over those two hurdles somehow because they're amazing and we know they're an amazing company, but let's just say theoretically, play along, they get over that. Then you've got another problem. So Helix preset files weigh tens of kilobytes. Like I don't think I've ever seen a Helix preset file that's over 20 kilobytes. Maybe there's some big ones out there that are 100, but you don't see megabyte sized Helix preset files because, I believe they're just JSON, I think, or XML. I can't remember, JSON, I think, basically, which is just a representation of the data in there. You can open them up in an editor and see they're not like a specialized format. So one NAM file is like, 50, 60, maybe even 100 times the size of a Helix preset file. So that would open the door to needing new flash partitions on the Helix. I don't know how much storage it has, but I'm guessing it's quite limited. You would need a new HX edit. You would need a new backup system architecture because everything is just suddenly bigger. And then on top of that, you would have to make sure that the Helix could even sustain that level of storage. I don't know if they found a way to compress them or whatever, but I just don't think the Helix storage itself, I don't think it could sustain that because it seems to me it has an intentionally low amount of storage on there, hence the IR limit and the preset limit, because obviously they've capped that because of space considerations. They didn't ship this thing with an SD card like the Quad Cortex has, or, bigger storage like some of the other modelers. So that to me, like once you get over the hardware, software, theoretically, that would be another roadblock that would be really difficult for them to get over. Maybe they come up with some amazing compression algorithm where they can take a 10 megabyte NAM capture and compress that down to 100 kilobytes. Still, I think you would run into a space issue very, very quickly. All that aside, and all that to say that I don't think the Helix Floor is capable. The hardware is just, it's locked into 2015. Like the only thing that would make the Helix Floor support NAM blocks is a hardware refresh, I'm afraid to say. There's just no way that you could support NAM blocks on there. That leads to the next question and a point that I made at the beginning of the video. Okay, NAM blocks are out. We know, I'm pretty certain that this could never support NAM blocks. I don't think you could even hack them in there. Even if you could, they'd be terrible. But could Line 6 create its own capture system? Could Line 6 have its own profiling technology that maybe is a little bit more efficient, doesn't have large file sizes from the WaveNet neural net files that our neural amp modeler does? And technically they already do, I guess you could say. Line 6 already writes every Helix amp by hand with component level modeling. If you go on YouTube, there's a great video on there. I think there's a couple of them, but they actually show you they have the circuits of the devices like an amp, and they will model the components inside there in software. And it is very precise in that some of their models get really, really close and they kind of do it on that component level, but it's not a machine learned process, it's math. So clearly is capable of processing some of this math, and they've done it. So it's DSP level math, it's audio-based math. So the DSP chips are able to take these models they've created and it's DSP code and they can run it, and they've made it into this efficient beast of a device. So they could roll their own Kemper style capture if they wanted to. They could build a PC-based capture app to record your amp, maybe an optimizer that crunches those recordings into a DSP efficient Shark micro model. And then they would still have to create a new firmware and UI to load the new block. But in theory, they could create something on there. But there are other hurdles because the device is older as well. One of the hurdles would be DSP budget. So they would have to compress the model so the realism would drop in terms of that. The R&D costs alone of that, building a profiler from scratch would be expensive. Obviously, it's a leap to go from component level modeling to audio-based neural net modeling or whatever approach they would do. I don't even know how they would do it, to be honest with you. But I think it would be a very huge task, probably not worth the money for them to do that, because it's one of those things where the costs would just it would probably outweigh what they're bringing in for the Helix at the moment. Like the Helix the sales have probably slowed down over the years. They're probably not selling as many Helixes as they were in 2015 or 2017. A 10-year device. Some people are really adverse to old tech, even though the Helix continues to be reinvented, and the Line 6 team have done a really good job of optimizing the software, as I said. But people just have it in their heads that they need new and shiny stuff and something constantly new and released. But these Shark chips inside, they're not a chip that needs a refresh every year. These are highly specialized low latency audio chips. They do one thing really, really well. So yeah, they brought out new Shark chips. They've got obviously the Shark Plus chip series, which the Quad Cortex uses. You know, they're probably constantly reinventing this stuff, but there's no need for manufacturers to constantly have to use the latest and the greatest. It does limit the software and what you can do because of the DSP side of things, but as we've seen with the Helix, they've managed to squeeze more juice out of this thing over a 10-year span just because good software development, you know, I guess critical thinking and, you know, thinking about every line of code they use would obviously add overhead, so only writing what needs to be done, going back and revisiting old code, rewriting engines, all that kind of stuff. That's how you keep reinventing the device because the hardware is still capable. Sure, you may hit the DSP limit if you're a heavy user, but a lot of people don't hit the DSP limit, and there are kind of workarounds you can do to get around that. So all that to say, could they ship a light capture? Maybe. Maybe they could. They could maybe bake the neural net down to a lookup table plus some heuristics, you know, and they may call it like a Helix amp capture or something, but sonically it would sit between their current models and a full NAM, and I think you would never beat what you currently get on the Helix. Like the capture quality just would not be as good as what the Helix currently offers. So here's the red pill moment, and I've said this a few times throughout the video.
You take the red pill.
But today's Helix is locked in 2015. There is no way they could add NAM block support to this. And as I was saying, even if they could, it would not sound good. It would not be what people wanted. It would be so much compromise and so much work for them to do that I just don't think it's worth the investment and the time. You know, if you're feeling a little bit downtrodden about that, you're thinking, before you start thinking, okay, I'm going to ditch and go to a Kemper or get a Quad Cortex, there are workarounds that you may not have even thought about that you could actually do. So one of those is you could actually get a Tone X1 pedal. You've got two different flavors of the Tone X. You've got like the Tone X1, which is small and cheap. That can play the captures profiles. Then you've got the larger Tone X. They're both pretty affordable devices, but if it was me and I wanted to add a little bit more shelf life to my Helix, a little bit more power, have the ability to have NAM captures, I would buy the Tone X1, which is about 150 US dollars, around about 300 Australian dollars. I would stick that in the Helix FX loop, and then I would use snapshot switch processors, presets to actually kind of use that in place of amps. And that right there, you would not have to use an amp on your Helix, which would free up some DSP, which means more pitch effects. It means more cat amps. Sorry, not amps. It means more modulation effects, reverbs, delays, just by putting that Tone X in the FX loop and not having to add in an amp or a cab onto the Helix itself, or adding a cab, having a capture of an amp, whatever your desired flavor is. That right there to me makes the most sense because it's affordable. You know, you don't have to go buy a brand new expensive Quad Cortex. You don't have to go buy a Kemper MK2. You don't have to go buy an expensive fractal unit. You're increasing the shelf life of your Helix, which Line 6 shows that they've been committed to doing anyway with software updates. There is another workaround. If you're a bit of a DIY or a tinkerer, you could actually build your own Raspberry Pi NAM box as well. You could get a Raspberry Pi 4 with the low latency audio HAT bundles, and then use two light captures at 128 sample buffers plus impulse response. You'd be looking at probably around about, I don't know, 70, 80 US, around about 150 US Australian dollars to do something like that. But here's the thing, if you're getting into that territory, you're better off just getting the Tone X1. But if you're a tinkerer and you like to build things, that's an option. I mean, I probably wouldn't do that because I don't have the time. But that's kind of, those are two options that you could explore if you did want NAM model support on there. You can do it now. Sure, it costs you money. It's not a free software update from Line 6, but it is going to give you what you desire. Or if you're like me, maybe you don't care. Maybe you don't hit the DSP on the Helix enough to really want it. You're happy with the amps and cabinets on the Helix. You're happy using an amp and an impulse response, which is what I do with the Helix. and I get a really good sound for the stuff I'm doing, but I understand that some of you are power users, some of you do hit the DSP, so my recommendation, tone X1 into the FX loop, and then you've got NAM. You've got a NAM block basically. Yeah, you're sure you had to pay some money for it, 150, 300, whatever, but you've extended your device. The dual 21469 chips, obviously, as I was saying, they live in 2015, and physics, they just don't allow NAM blocks to work on the Helix without compromise or without a lot of work from line 6 to do that. So as I was saying, get a Tone X, build a Pi, or if you're just completely unhappy, get a Quad Cortex, get a Kemper, whatever you want. But yeah, basically those are the options, and hopefully that kind of helped explain things. And sorry to shatter the illusion that there was hope that this was coming. But yeah, we're not getting NAM blocks, but maybe line 6 surprised us with their own profile capturing technology. I doubt it. I seriously doubt it, but that is an option. So yeah, thank you very much for watching to the end of this rant. Sorry if it didn't make sense. Hopefully you were following along with all of that. And if you made it to the end of this video, thank you very much. Like the video, leave a comment below with your thoughts, and maybe I'll see you around the next video. Thank you for watching.